Hi, so today I'm going to do a lesson on the primary trigonometric ratios. Now it sounds like a complicated word, but stick with me because it's not too bad. So, basically what we're going to start with is we're going to start with a right angled triangle. Now if you remember from the last lesson, this meant that we had 90 degrees. And I also showed you from this across is our hypotenuse. Now, when we're doing primary trig ratios, there's one other thing we have to look at, and we have to name the other two sides. So, and when you name the other two sides, it's based on the angle that you're using. So, if we're using this angle, which I'm going to make blue and label A, what happens is that across from here, so if we go all the way across, the side that is across from that angle is called the opposite. And the side that is right beside it is called the adjacent. Now I'm going to show you something else, like because it matters what angle you're using. Let's say that this is our green angle and this is angle B. If that is the angle that we're making reference to, then this would then be the opposite. And this would then be the adjacent. Now I put it in different colors so you could see it clearly. Our primary trig ratios, I'm going to write them in terms with respect to angle A. Is sine A is equal to the opposite side, or the length of the opposite side, divided by the length of the hypotenuse. So that's the first one. Cos of A, or the cosine of angle A, is equal to the adjacent divided by the hypotenuse. And the last one is tangent, or tan, of the angle A is equal to the length of the opposite divided by the length of the adjacent. Now there's a really cool way that you can remember that, and it's kind of already up there. But this one, because it's sine opposite over hypotenuse, sine opposite hypotenuse, cos adjacent hypotenuse, and tan opposite adjacent, and you can remember it by SOHCAHTOA. SOHCAHTOA. Okay, so now that we have that done, let me show you how we actually use these in an example. So the first example says, list the three primary trigonometric ratios of the following triangle for angle A. So the very first thing you're going to do is label the sides. And so because it's angle A, I'm just going to note it here. And we're going to do everything based off angle A. So angle A, across from it is our opposite. Beside it is our adjacent. And then across from the 90 is our hypotenuse, or our longest side. So then what you're going to do, because it wants us just to list the 3 primary trig ratios, we're going to list sine A. Now from above, sine A was opposite over hypotenuse. So the length of our opposite side is, or we can write it like this. The length of our opposite side was 6. And the length of our hypotenuse was 10. So sine of A is 6 over 10. Let's do cos. A was adjacent over hypotenuse. Our length of our adjacent is 8. And our hypotenuse is 10. And the last one, tan of A, was our opposite over adjacent. And that was 6 over 8. So it's really important just to make sure that you label your sides correctly. Okay, so moving on to the second example here, I'm going to show you how to find the length of an unknown side when you're given an angle and one of the other sides in a 90-degree triangle. So the first thing you're going to do is take a look at where your angle is. So in this example, I can see that my angle of reference is B, and I'm going to label the sides exactly to fit that. So again, across from it is our opposite. Beside it is our adjacent. And then across from the 90 is our hypotenuse. Okay, so it's really important to label those first. They make it really easy. Now, the unknown side, when I do these, I always think, what do I know and what do I want to know? So what I want to know is I want to know the opposite side. And what I have is the hypotenuse. So then I think back, which one of my ratios has the opposite and the hypotenuse? And if I look back up there, I know that sine was opposite hypotenuse. So in this case, I'm going to use sine because it's opposite over hypotenuse. I want the opposite and I have the hypotenuse. So it just makes sense to use sine. So we'll set it up. Sine of 63 degrees, because the angle always goes with our sine, cos, or tan, is equal to our opposite, which is B. We're going to solve for that, over our hypotenuse, which is 101 feet. Now, in this example, because B is on the top, all you're going to do is take that 101, move it to the other side, and multiply. So it becomes 101 times sine 63 equals B. Now, when I calculate that on my calculator, I do 101 times sine 63, and I got 89.99, so it's basically 90 feet equals B. Moving to the second side of the page, I'm going to try another example. I'm going to show you what happens when the unknown is on the bottom. So again, we're going to label the sides. This is 36 here, so our opposite is across over here. Our adjacent is here, and our hypotenuse is here. So again, I'm looking at, I want to find the hype or the hypotenuse, and I already have the adjacent because we know that that's 15. So hype and adjacent, The one ratio that has both the adjacent and the hypotenuse is cos. So I'm going to use that one. So again, same setup, cos 36 degrees equals our adjacent, which is 15, over our hypotenuse, and we don't know that, so that's why. Okay, this time what you're going to do, because it's on the bottom, is you're going to, what I say is swap them. Because if you swap them, it just makes it really easy. So it becomes y equals 15 over cos 36. So then when I plug it into my calculator, 15 divided by cos 36, I got 18.5. And that's in meters. Perfect. The last example I'm going to show you is how to find an unknown measure of an angle. So again, we're going to do the same thing. Our unknown is right here, so we're going to label our sides according to this angle. So here is our adjacent. Our opposite is here, and our hypotenuse is here. Okay, now this one works a little bit differently. In this case, I'm going to list the two things that we have. So in this case, we have the opposite and we have the adjacent. So if I go back to our ratios, the one that had both the opposite and the adjacent was tan. Tan equaled opposite over adjacent. So we're going to use that one. And I'm going to set it up. Tan of A. A is the angle we're going to solve. Equals 21 is our opposite over 25, which is our adjacent. And then you're just going to divide that. 21 divided by 25 becomes 0.84. Now, what happens is you're going to use your calculator and shift tan. So it kind of looks like this, tan to the -1. If you push second function and whatever tan is, it's usually right above that button on your calculator of 0.84. And when I do that, I get an answer of 40 degrees. So now I know that this angle here is 40 degrees. And that's it. Have fun, guys.